Ever looked at a spreadsheet and wished you could unlock the secrets in seconds? Before I learned to program with Python, I would spend hours manually crunching numbers to analyze my data. Now, tasks that once took days are done in minutes. And today, I will show you exactly how it's done. In the next few minutes, you will see how Python can take you from data overwhelmed to data empowered. Hello, everyone. I am Dr. Uohna Thiessen. I am the Director of Artificial Intelligence at a company called NEXTELLIGENCE의, and I am a Udacity instructor. I am also a Python enthusiast, and so I'm excited to share with you on one of my favorite topics, Python for data analysis. What makes Python so unique for data analysis? Well, first of all, Python is the Swiss Army knife of data science and data analysis. Imagine you have a messy data set of sales reports. With just a few lines of code, you can clean and explore and analyze and visualize and model your data effortlessly. Python stands out for a number of reasons. Its flexibility and power. Basic data cleaning and processing can be done from complex to some simple to the complex. Python does it all. And then there's its rich ecosystem of built-in libraries that take all of the drudgery out of complex analysis tasks. Python also has a massive supportive community of developers that provide countless resources and solutions that are just a search away. Python is easy to learn. The syntax is like a natural language, so coding with Python is almost intuitive. Now, Python and the data revolution. Data analysis isn't just a skill anymore. It is a career superpower. Companies are drowning in data but starving for insight, and that's where Python comes in. Python powers all our daily technology, from Netflix recommendation engines to Tesla self-driving cars. Leading companies like Google and Facebook and Amazon, even NASA leverage the power of Python for data science and data analysis. And the best part is, like all of these big tech companies, you too can use Python because Python is open source, meaning it's free for everyone to use forever. Now, let's talk about the power of Python and what it can actually do. Some of the features that make Python a favorite among us as data professionals include its automation. Remember those libraries I mentioned? Well, Pandas and NumPy specifically automate all data cleaning, data processing of all structured data, all tables and spreadsheets. And then there are the stunning visualizations tools like Matplotlib and Seaborn을 and Plotly that create graphs and charts and even dashboards with ease. And then, of course, predictive modeling. There's sklearn and TensorFlow, and you can use those to build simple or complicated machine learning models to forecast trends and inform data-driven decision making. And then there's beautiful Soup for web scraping and LTX for text analysis and sentiment and text analysis. And there are no compatibility issues when it comes to Python. It works smoothly on Windows or Macs or Linux. All right, let's talk about one of those Python modules, my favorite, Pandas. And hopefully it will become yours as well. Pandas is amazing. Think of it as Excel, but on steroids. With just a few lines of code, you can load your data, multiple formats from CSV, Excel, files, SPSS, you name it. You can clean your data with Pandas. It handles missing values, outliers, transformation. You can do statistical analysis with Pandas. You can also use it to summarize and generalize your data, visualizations, and you can get transformations from your data set using Pandas to help you understand your data. Now, before you can use Pandas or any of the modules, you have to set up your environment. And to do that, you have options. You can install Python directly. You can download it directly from Python, or Or you can use Anaconda, which is the all-in-one package, and it includes the Jupyter notebook. Or you can install it on using the terminal with pip. It's Windows, Mac, Linux, or any, you name it. Now, once you have Pandas installed, you have to choose an IDE. And of course, we all appreciate the convenience of working with the Jupyter notebook. It just makes it so easy and convenient, and it's just ideal for interactive coding. But there's also PyCharm and VS Code, which provides some of the offline capabilities. But my favorite is Google Colab. This is the cloud-based version, and it requires no installation. You simply log in, grab, load up your data file, and start coding with Python or Pandas. Pandas. Now let's get started. Let me show you just how easy it is. So once you are in the Jupyter notebook, you first have to install the Pandas module. Once you've installed it, you import it into your Jupyter notebook, and you can start using. Next, you have to get data, because all data projects need data. So you can read or write in your data using, again, Pandas has modules for that with the pd.read _ CSV or Excel or SPSS. And once you have read in your data, it comes in as a data frame. And with that data, the Pandas data frame, there are so many built-in functions. So you have dataframe.head, or as we say, df.head, that will give you the first 5 rows. Then you have df.info, that will give you the data type for all of the columns. And then you have df.describe, which will give you the basic statistics of all of the columns in your data. Then you have .shape, will give you the dimensions of your data. And you can do .tail to get the last 5 rows. And there are several others like these. And so you can use all of them to, explore it and, just kind of look at your data. And once you're sure that this is the data set you want, and now you have an idea of what are the data types contained in, then you can move on to some of the basic manipulation. So you can filter your data, you can move certain columns or rows, you can rename rows, you can drop rows, you can convert rows from numerical to categorical or vice versa, and you can make all of the transformations and processing you need just using the Pandas functionality. Now you can also go on to do things like remove the missing values. Once you've found the missing values, then you can find duplicates and remove those as well. Or if you have missing values and you may want to do some other option of treating those missing values, you have the option of filling them with the mean or the mode or the median or other types of manipulation of your data. Then you can now go on to plotting, because there's some things about the data that you will not be able to understand or be able to appreciate in the tabular form. But once you start plotting the graphs and charts, it becomes even so much more easier to understand. So you can start with the basic dot plot, or you can move on to using some of the more advanced features of Matplotlib to do line plots and bar plots and scatter plots. Or if you want, for those of you more aesthetically minded, you can use Seaborn for those more stunning visualizations, for your presentations, for data storytelling, and so on. So there are lots of capabilities with Python. You can also move on now to the more advanced data science tasks with your Pandas. You can now combine that with NumPy, which is for advanced numerical computing, and it makes Pandas even that much more powerful. Now, once we have grasped the fundamentals of Pandas, I think you're able to move on to some of the other modules, right? So we have, of course, the sklearn. This is where you have all of your already formulated fantastic machine learning algorithms for data modeling. You have the linear regression for trends and uncovering insights from your data. You have logistic regression for making predictions and classifications. You have the support vector machines and and the decision tree and the random forest and on and on and on. There is a whole lot to Pandas, but you took Python, so you need to go in there and get started. But I want to give you some advice before you go in. There's some things that some pitfalls I can help you avoid and some best practices, right? So when you're working with your data, you want to always check for the missing values before diving in to the analysis. And once you've found the missing values, you have to determine what is the extent and the type of missingness, because that's going to determine how you're going to correct or treat the missingness, right? And then when you have done some manipulation and transformation or reshaping of your data set, make sure to correctly reset, or if not, set your indices, and that make sure that it matches to avoid the mismatch, which can cause serious errors. And then in general, just write clean, efficient code with comments, because that's going to save you a lot of headache in the future. So I think you're ready to go out and explore. Grab a Jupyter notebook near you and any one of the many sample data set and start experimenting. If you like this video, please like, comment, and subscribe. And tap the notification bell so you don't miss any more of our exciting video series. Thanks for watching.